Welcome back to Think Cosmos, where we ponder the universe's deepest secrets and wonders. In 2024, astronomers discovered something staggering. A record-breaking black hole. So massive and so close to us that its existence is shaking up everything we thought we knew about stellar evolution. Meet Gaia B3, a 33 solar mass black hole, lurking just 1,600 light-years from Earth. That's closer than many of the stars we can see with the naked eye. Yet until now, we had no idea it was there. It's completely dark. It's completely dark. It emits no light. It doesn't devour gas, but it pulls, subtly, invisibly, on a sun-like companion star. And thanks to the European Space Agency's Gaia telescope, we finally saw the telltale wobble. This is more than just a new object in the catalog. It's a cosmic revelation that redefines what we know about how stars die, how black holes form, and how many silent giants may be lurking in our galactic neighborhood. How we found Gaia DH3, a star with a secret. The discovery didn't come from a dramatic X-ray burst or gravitational wave alert. Instead, it came from precision astrometry, the exact tracking of star positions and motions in space. The Gaia Space Telescope, launched in 2013, has been mapping the positions of over 2 billion stars in our galaxy. In 2024, a team analyzing Gaia data noticed something odd. A sun-like star was making a strange wobble in its motion. That wobble could only mean one thing. It was orbiting something massive, but there was no visible companion. No light. No infrared glow. No X-rays. Whatever was causing the wobble was invisible and massive. Further calculations revealed that the invisible object had a mass of at least 33 times that of the Sun. Far too heavy to be a neutron star, white dwarf, or planet. It could only be one thing: a stellar black hole. And not just any black hole. The most massive known stellar mass black hole in the entire Milky Way galaxy. Why 33 solar masses is a big deal. Most stellar black holes, the kind formed from the deaths of massive stars, weigh between 5 and 15 solar masses. Until now, the upper limit seemed to cap out around 2025 for anything formed naturally from a single star in the Milky Way. Gaia B3 blows past that ceiling. Its enormous mass suggests it formed from a star that was incredibly massive, likely over 60 times the mass of our Sun. Extremely old, dating back to when the Milky Way was young, metal poor, meaning it didn't shed much of its mass before collapse. This matches theories that the first generations of stars, often called population 2 or even population 3 stars, could form much heavier black holes due to lower radiation pressure and mass loss. If Gaia B3 is a relic from that ancient time, it means we are living near a fossil of the early galaxy, one of the few remaining fingerprints of how things worked when stars first began to shine. What else could be hiding? The silent black hole population. And here's the truly mind-bending part. Gaia BH3 is likely not alone. Because it doesn't emit radiation, it couldn't be spotted by traditional means. Only its gravitational pull on its companion star gave it away. And if it weren't for Gaia's incredible precision, we might never have known it was there. That means there could be tens of thousands of dormant black holes like it in the Milky Way. Dark, silent, and effectively invisible, unless we're lucky enough to catch their subtle gravitational influence. Future missions, like NASA's Roman Space Telescope and ESA's LISA gravitational wave detector, may uncover even more. Together they could map the hidden population of stellar black holes and show us what kind of death black holes really follow their stellar lives with. a new laboratory for black hole physics. Because Gaia BH3 is relatively close, just 1,600 light-years away, it becomes an ideal target for future study with next-gen telescopes like JWST, which can probe its companion star spectrum in infrared, an extremely large telescope for direct radial velocity tracking. The SCA, Square Kilometer Array, to search for weak radio emissions or companions. Gravitational wave observatories, to see if it's part of a future black hole merger. We may be able to measure its spin, refine its mass, and reconstruct its formation history, all from right here in our corner of the galaxy. It is the perfect cosmic laboratory to test models of supernova explosions, stellar collapse, black hole formation thresholds, binary system, evolution. Why, this changes the game. Gaia BH3 doesn't just reset the record books. It resets our cosmic expectations. If such a massive, quiet black hole has been hiding so close to us, undetected for centuries, what else might be out there? Could we be on the verge of discovering hidden triple black hole systems? Intermediate mass black holes that bridge the gap to supermassives, or even the remnants of the very first stars, still lurking nearby. We now know to look not just for loud, bright, high-energy black holes, but for the silent ones, the ones that whisper in the subtle motion of their stars that gravity never sleeps.